want to talk about like what do these systems look like to collect this information. So all these examples are based on personal experience of building these kinds of systems. It's what I do professionally, and these large scale systems can be complex. Now I think we've been doing this for about 10 years. And we've done some about 20,000 pieces of equipment globally. About this number's around data, maybe like 1,500 SMT lines, 2,000 pieces of test equipment. And I've also gotten the opportunity to see how different factories have set up their data collection systems, the choices they've made for smaller factories and for larger factories. And so I've curated this like reference architecture piece of the kinds of components that people have tended to adopt and what they tended to need to add or fix as they've grown these systems in scale of complexity. And at the end of the day, it tends to look like something like this. And I'll walk through this piece by piece. The first one is, streaming event broker. So there's a need to organize how you're like collecting and sending data. You've got two choices. I send data as it's generated. I sort of push it, or I only pull it on demand. The pull on demand was more popular sort of earlier times. This push methodology or streaming, event streaming, is more popular now because it sort of gets data out to a broad set of audiences as quickly as it's available from the source equipment. People use a variety of technologies for this. I'll put three up here. Sometimes people use technology called MQTT. An example of an open source version of this is a Mosquito event broker. Other people use AMQP, a different protocol for the same purpose. A free example of that is RabbitMQ. And larger enterprises use a tool called Kafka sometimes. There's many implementations of it. But at the end of the day, they're all versions of the same thing, which is I have just a clearinghouse of data, and people publish events as they happen. Other people can subscribe to the ones that are relevant for them and then consume them down. And one event can go to many different consumers that are interested in it. And that's really the key point. It sort of decouples who cares about the information from who's making it. Yeah. It's actually, so data warehouse would be the SQL concept of it. So data warehouse would be this, but in a database. This is actually more ephemeral. So it's like, event happens, I say, hey, I just finished production cycle. I'm pick and place 15, and here's everything I know. You put it on the broker, and then anybody who cares about that would be listening. They would get a copy of it. They could choose to put it in the data warehouse, or they could forget about it. But once the event has happened, it doesn't actually get immediately stored. And so oftentimes it's coupled then with a data warehouse, but this is sort of like the real-time version of that. So this is sort of like the organizing concept. How many people here have like heard the term unified namespace or are familiar with that? I got one, two, couple. So unified namespace is a popularization of this concept, which is, hey, I'm going to be streaming events. I'm going to be sending things as they happen from a variety of people. So what do I need to agree if I'm going to do that? I need to agree on, say, a topic structure or a way of organizing the information. I need to know, maybe I'll do like factory line, machine, area of the factory. So that way people can subscribe to own the data that's relevant for them. If I'm in this building, I subscribe only to my building. If I'm in the entire factory, I subscribe to the entire factory. If I only care about a given factory line, I subscribe only to that line. And in order to do that, you have to agree on, okay, what are you going to call that line? What are you going to call how are you going to organize things? What is a line? So that's sort of what the unified namespace concept builds on this overall concept. It's just how are you going to organize things in this streaming event broker. But if you go sort of downstream from there, who is producing the data, you tend to find these two very different kinds of systems. You find these systems here, call them like advanced equipment. So this would be pretty much everything on your SMT line. It would be your testers, even probably your functional testers. These are things where maybe you bought it from a third party. It's got a full-on computer in there. So these things are sending like very structured data reports. The test result file, if you include all the measurements from this guy machine, might be like 1 or 2 megabytes of just data about exactly what it did. It's in the XML or it's in JSON or it's in like some weird hand-built CSV thingy. But it's a file and it's got a lot of information. So you got that kind of equipment in your factory. But then the other kind you have, call them like the more simple systems. Maybe I just have like a humidity sensor like shoved in a room somewhere or next to my factory line that just reports the humidity in the air every 10 minutes. Or, I've got some legacy PLC on like a press machine, and all it can do is tell me like some current sensor values. So you got this kind of data as well. And one of the challenges that you have is these two bits of data, they're like fundamentally different from each other. This one like is already knows which production cycle it's a part of. It's a whole structured report. It might not be in a standard format, but like at least it's sort of got all the pieces that are put together. These tend to be just disconnected time series of individual sensor values. And if you want to stream them, you kind of want to put them together into like which values care, when do I want to sample them, which ones relate to each other. But you have to do some work to actually build up that like set of information you want to send. Whereas on this side, the creator of the machine or the equipment already did that for you. This is the primary challenge you have on the data collection side. In addition to this how do you actually collect and get this data out and send it to your event broker, is you got these two fundamentally different kinds of data. And this one requires some modeling or some choices before you're ready to send it. So then on the consumer side, you've got your MES, for example, that might want a lot of this data. You might have some other enterprise systems like an ERP, might want some of the data maybe for back flushing or for inventory or for updating a work order status maybe. And then you might have a lot of desire for some advanced shop floor control use cases. So for example, maybe you want to do an advanced SPC use case where you've got some measurement data streaming in and you're reacting on to the distribution of one of these parameters getting too wide, or you're looking at CPK and you want to do something proactively on your test equipment, for example. So a lot of other users where you just directly want the feed of data, you'll analyze it and maybe take some action. And then, you also have all of these other databases where you might want to store this data, especially if you want to make it available to an AI tool. So you might have a data warehouse that you store it in. Sometimes people use purpose-built time series databases because the data is high volume and it can be easier to store. You might need to do alerting based on it or a lot of telemetry in order to ensure the data is flowing correctly. But at the end of the day, so this kind of tends to look like a system like this, where you might swap in, a different event broker technology like MQTT or AMQP or Kafka, and maybe you only have this kind of data to start with, but most people also have some of this as well, and you have to sort of merge them together. And then on like this block 2 and block 4, what it ultimately tends to look like is something like this. This is sort of like how we tend to see these data systems structured, which is, okay, I got a bunch of systems over here. Maybe there's a bunch of internal links, but there's something I'm connecting to. So this might be the individual machine, connecting directly to this particular place and pulling its files. It might be, I've got a SCADA system. Someone bought like Ignition or like some other SCADA system in their factory. And so actually I've got a bunch of systems already pre-wired and I've got some OPC UA tags. So then if I'm on this side of the fence, I have to decide what data I want to pull. If I'm on this side of the fence, the machine has already decided for me. It's giving me a file or giving me some structured data. I need to put it together. And then now finally I've got my data into my system, but it has not been standardized yet, right? Like not everyone's using IPC CFX, or it may not even have the right messages for your equipment. So somebody's got to figure out, okay, what is the unified taxonomy? Like, what do I want to call, what do I care about organizing? And I'll call this sort of like standard data. Okay, I want alarms. I want to know when an alarm happened or a fault happened on a machine. Great. Let me go look at all my pieces of equipment and identify, okay, what part of this message or which of these messages means an alarm happened. How do I figure out like the alarm number or the human readable name? Okay, let me pull that out and put it over here. Let me figure out like a cycle time or how many units were processed. Okay, let me just summarize that work. Let me figure out if you were doing an inspection. Okay, where do I find the inspection results? Let me figure out if you actually did any measurements. You have any measurement data to report for me? Great, let me just collect all my measurements together. So you sort of tend to build a system that kind of looks like this. You've got some data collection, some protocol translation, And then the hard work of actually interpreting, understanding, and homogenizing all of these various different schemas, some of them open source, some of them standard, some of them proprietary, to finally get this coherent, unified namespace of your factory, which is, I finally know when there's a cycle done on any of my machines. I finally know the inspection results pass or fail, and I've got some vector details.